Hello and good morning dear students. So today is 10th of August and in the previous class we have started differential equation. We have done exercise 9.1, what do you mean by order, degree, and we have also started how to solve a differential equation by using separation of variables. And yes, we were doing exercise 9.4. In the last class I've done till question number 3 part 1 and now we are starting from question number 3 part 2. The question is same, solve. So on the board you can see there is no differential equation given to us. Okay, a differential equation is not given to us. We have to make the differential equation, right? Or else, even if this is given to us, we have to solve. We have to solve and find the value for y, right? So by using separation of variables, isn't it? So what we have learned before is keep x together, keep y together. That's the meaning of separation of variables. And then once it is separated, then we can take the integration, right? So since there is dx and dy, I'm going to take one of the term to the right hand side. Okay, so that will give me x into 1 plus y squared dx, which is minus y into 1 plus x squared into dy. Okay, now what you see is there is dy, there is y. There is dx, there is x. So try to bring this 1 plus x squared out here and try to take this 1 plus y squared down out here in the denominator. Okay, because we are doing separation of variables, right? So therefore, which implies x into dx and then divided by, bring it here, 1 plus x squared, which is minus y into 1 plus y squared into dy. So now if you see, the variables has been separated. X is in the left hand side, y is in the right hand side. So now what we can do? Integrate. So integrating both sides, what we get is x1 plus x squared dx integration, which is equals to minus y 1 plus y squared integration dy. Now we have come across this type of integrals before. I've told you before in previous classes, if the power in the numerator is lesser than the power in the denominator, what we'll do? We'll substitute the denominator as another variable, right? If the powers are equal, we'll try and make the numerator as denominator. If the power in the numerator is greater, we'll divide. So three cases. Here the power is less, so hence we have to substitute. And we know how to do, substitute this as P, substitute this as Q. Alright, so I'm giving this as I1, which is equals to minus I2. Now your job is to find the value for I1 and I2. Alright. Alright, so give this equation as equation number 1. Your I1 is this, your I2 is this. Okay, so now I can clear this. And when you solve, how to solve I1? I told you by substitution. Assume this as P denominator, okay, and you'll be getting the value for x dx, dp by 2. Similarly, y dy dq by 2, okay, according to your substitution. So I1 will be, this is dp by 2 divided by p, so which means half log p. And what is the value for p? Half log of x1 plus x squared. So this is the value for I1. Similarly, when you solve it, you'll be getting the value for I2 as half log of 1 plus y squared. So this is the value for I1 and I2. Alright, so now what we'll do is we'll put this value for I1 and I2 in equation number 1. So from equation 1 you can write down, because that's our main solution. From equation 1, what was the equation 1? I1 is equals to minus I2, right? So I1 is half log of 1 plus x squared, which is minus half log of 1 plus y squared plus c. You can keep this answer till here. That is your final answer. So pause the video and note it down. Alright, so now we move to the next question, that is question number 4 part 1 and 4 part 2. Okay, so I'll explain 4 part 1 first. So question 4 part 1 is dy by dx equals to x plus 1 divided by 2 minus y. What we'll do, the first step is cross multiplication, that is separate, right? So dy into this and dx into this. So it is now already been separated. Alright, so the next step is integration. So integrate both sides, you'll be getting integration of this. Now how will you evaluate further? Is just by multiplying term by term, isn't it? So 2 is a constant, integration dy minus integration y dy is equals to integration x dx plus integration dx. Okay, and you know what to do. This is your final answer. So please pause the video and note it down. And move to question number 4 part 2. In 4 part 2 we have dy by dx is equals to e to the power x plus y. Okay, we also have to separate the variables. So the only thing we can do out here is, I cannot change anything out here, keep it as it is. On the right hand side, we can write e to the power x plus y as e to the power x into e to the power y. I hope you are clear with this. I'm using the product law, laws of indices. Okay. Now what to do? Separate the variables. So dy by e to the power y, e to the power x into dx. Now this is not possible, so bring it up. Numerator, e to the power minus y dy is equals to e to the power x dx. And now you can solve this further. Okay, so pause the video, note it down. Alright, so next question I'm taking is 5 part 2. 5 part 1 you can do it yourself. 5 part 2 is solve dy by dx plus 1 plus y squared divided by y is equals to 0. Separate. How to separate? You can clearly see this whole term contains y, right? So take to the right hand side, it becomes minus. Now you can think what to do. So you cross multiply it, is equals to minus dx. I hope everyone is clear till here. I hope everyone is clear till here, right? And now we have to integrate, so take the integration sign. And this you have already done just before, isn't it? So it is nothing but half log 1 plus y square. If you want to take it as substitution, you can keep it as I1 and solve. You'll be getting the same answer. If you know it, you can directly write. Okay? And which is equals to minus x plus c. So please pause the video and note it down. Alright, so next question is number 7 part 1. The question is dy by dx equals to log x. So the first thing is to separate, so cross multiply. You'll be getting dy is equals to log x into dx. It has been separated, right? And now what to do? Integration. So after integration, you will be getting integration dy is equals to integration log x dx. Now integration dy, we know it is y. No problem. But integration into log x, how will you do? Pause for a while and think. Integration of log x, we don't have formula. But if you remember, we have done integration of log x in integration by parts. We have done integration by parts. By parts. Do you remember exercise 11.8? Sorry, exercise 8.11. We have done integration by parts in integration, right? And we have learned ILAT or LIATE, right? LIATE. And log x, how we have done? Integration of log x into 1. So log x is logarithmic function and 1 is algebraic function. So hence, which is your u? This is my u and this is my v. So log x, integration of dx minus integration ddx of log x and integration of dx and dx integrating by parts. So see, I've told you before I start this chapter, I've told you yes, in this chapter integration is must. We have to know integration properly. Okay, so whichever formulas we have done before, please don't take it otherwise. Otherwise, you'll be simply messing up out here. You'll not understand what's going on. Okay, so please do learn the formula by heart. So this is integration by parts using LITE. Therefore, y is equals to integration of dx is x. So x into log x minus integration within the curly bracket ddx of log x is 1 by x. Integration of dx is x and then curly and then dx. So x cancel out. So I'll be doing this side, right? So this implies y is equals to x log x minus integration of dx. It is x and then finally plus. So this is how we have to solve. Alright? So please pause the video and note it down. Alright, so question number 8 part 1 and 8 part 2. Half I have done and half you'll complete yourself. Okay? So I'm just giving the hint. 8 part 1. This is the question. So what we'll do first is take your plus 1 to the right hand side, it becomes minus 1, and then the same thing, separation of variables, right? So x minus 1 divided by e to the power x, it is separated now. Okay, integrate on both the sides, and then here you have to separate one by one. Okay, integration dy is y, so this is x into e to the power minus x dx. If you separate, it will be x by e to the power x minus 1 by e to the power x, is it? So x by e to the power x means x into e to the power minus x and minus e to the power minus x dx. So this part you have to do integration by parts, and this you know how to do. Same thing goes out here. Dy by dx is equals to x tan inverse x, because cross multiplication x tan inverse x into dx, separated. Take the integration sign, this is y, and here you have to use integration by parts. Okay, so please pause the video and note it down. Alright, the next question I'm taking is question number 9 part 2, which is ISC 2012. The question is to solve, right? So this is the question given to us. Whenever you see dx plus dy something like this, take one of the term, directly you can take one of the term that side. Okay, so which we are doing out here. So I'm taking this term to the right hand side, it becomes minus. See, everything is same, just it is minus sign because I'm taking to the other side. Okay, so now what I can do is I can see x is common, I can see y is common, so take the common. Okay, x is common, y square plus 1 dx, y is common, x square plus 1 dy. Alright, so now the same thing again, separation of variable. So keep x dx divided by x square plus 1 minus y dy divided by y square plus 1. As they are separated now, as the variables has been separated, so now you can do integration both the sides. Right, so now we can do integration on both the sides. Clear? So now we can do integration on both the sides. So integration on both the sides, I mean, you know this integral, right? We have done it before, just few sums before. It is half into log of x square plus 1 and minus half log of y square plus 1 plus c, which is my final answer. So please pause the video and note it down. Alright, so the last question for the day is question number 9 part 2, which is ISC 2017, a very important type of question. So again, a similar type of question given to us. So take it to the right hand side, it becomes minus, and after you take the right hand side, see what is the common. Here x squared is common and here y squared is common. So please take the common terms. Okay, the moment you do that, now you can see property is, here it is x squared 1 minus y dy, here it is y squared 1 plus x dx. So hang on for a while and think how will be easy for you to separate. So I am keeping 1 plus x dx this side and bringing x square here, separated. Similarly 1 minus y divided by y square, separated. Okay, the moment it is separated now, please integrate. So integration, and now to solve this, we know how to solve. Separate 1 by y square dy minus y by y square dy, which is this. Similarly, minus 1 by x squared dx minus x by x squared dx, which is this. And we know this is log y, this is log x, and here it is. So therefore, I hope I can clear this. Please pause the video and note it down. Right, and after this step, a final step now, so which will give you the answer as y to the power minus 1 divided by minus 1 minus log y, which is equals to minus, sorry, this will be plus because minus sign is already out here. It is x to the power minus 1 and divided by minus 1, which is plus, minus log x plus c. So if I have to write it properly, then it will be minus 1 by y minus log y, which is equals to 1 by x minus log x plus c. So we'll keep this much, otherwise you can simplify further also. That choice is yours. Okay, so pause the video, note it down. And finally, assignments for today is question number 5 part 1, 6 part 1 part 2, 8 part 1 and part 2. One thing I will end out here with is, see, in calculus, if you want to really score good marks, then please do practice it every day. Every day you need to practice and do learn the formulas, and it is very interesting. If you give your 100% out here, it is very interesting and very easy to score the marks. Okay, so once again I'm telling you, from differential equation every year 8 to 10 marks comes. 8 to 10 marks is a huge amount of marks, and it's very easy. If you are clear in differential equation, then you are clear in integration, and if you are clear in integration, you will be clear in differentiation as well. So there is a link you can see out here: differentiation, integration, and differential equation. Okay, so please do practice it every day. Complete the assignments and the sums and submit it by tomorrow. Thank you.